Thank you.
Alright, welcome everybody. Thank you all for coming out tonight to listen to Bill. I'm just going to give a little intro and then we're going to get right into it. So for those of you who don't know, Bill Boller is a mechanical engineer with degrees from Stanford University and the University of Southern California. A fun fact about Bill, when he was studying at Stanford for his 2 degrees there, he paid for them by working in the University Fire Department and served as the president of the Stanford Student Firefighter Association. Bill has spent most of his career at Hewlett-Packard in executive positions, retiring as vice president after 34 years. At HP, he became close friends with, is it Jacques or Jacques? Jacques Littlefield, with whom he formed the Portola Valley and Alpine Live Steam Model Railroad on Jacques' Pony Tracks Ranch. Bill served as the first president of this club railroad. He also served on the board of Jacques' Military Vehicle Technology Foundation, which was recognized in 2007 by Guinness as the largest private collection of armored fighting vehicles in the world. Upon Jacques' passing, Bill became president, CEO, and chairman of the board of this organization. And it was Bill who initiated the effort to create the American Heritage Museum, not this museum, even though the name is similar, for this legacy collection. This one is located in Hudson, Massachusetts. Now, regarding railroads, what we're all here for tonight. Bill is well known for his technical knowledge of live steam model railroading, and with 4 other steam railroad enthusiasts, he co-founded a nonprofit for the protection, restoration, and legacy recognition of the 3 remaining 1882 vintage C16 class narrow gauge locomotives. And so tonight, Bill is going to be showing us some of his work and teaching us a little bit more about railroads, so let's give him a hand.
Is this on now? Can you hear me or do I need to turn the button?
Yeah, push the button.
Press the button.
Try that.
Yeah.
Okay. Thank you all for coming. I was asked to just give a presentation here on the Portola Valley and Alpine Railroad and some of our activities a few weeks ago, and I agreed to do that. And I didn't see the announcement about this until just the week before last. And to my surprise, there were two surprises in there. One was the fact that this presentation is now going to be on narrow gauge railroading, which it isn't, because I already prepared all those slides. It's going to be about modeling in live steam for 7.5-inch gauge in particular, and I'll get into more in a minute. The biggest surprise was the fact that it referred to me as an expert. That was a tremendous surprise, because I always thought that to understand what an expert was, you have to look at the origin of the word. It comes from X, which means a has-been, and a spurt, which is something that comes along in a very short instance. And so I want to be associated with it. In all seriousness, in talking about the live steam hobby, and for the most part of this is going to be about highly detailed modeling in a certain sense. If you think about our hobby of trains, you can start with toy trains, and then you can get models, and you get more sophisticated models, and the model can be a specific railroad, and then it can be a specific engine, and then it can be a specific engine at a specific time of its life, and then it can get extremely detailed, and then it can become operational, and you can run it on electricity or batteries, and then you can eventually say you'll run it on steam. And if it's on steam, then you can take various ways to heat it. Eventually you can get to coal, and you take all those and put them together at the total extreme. You find the most idiots you ever find in your life, the one doing it all in one. That's what we try to do. Now, out of fairness, if you really want to hear the experts in this, I've got to give some credence to some very close friends of mine. People in this hobby will recognize some of the names: Ron Schmidt, Jimmy Booth, Peter Mosley. Peter Mosley's father was in the hobby since forever, as a legacy. And a lot of what I'm going to talk about in the detail at the beginning of this, really, they deserve a lot of credit. They were the inspiration and helped me understand how to do a lot of that. I dragged them kicking and screaming into doing these narrow gauge in 2.5 inches to the foot. That's the size, I heard some comment earlier, that's the size where up to that scale, you continue to think that if you get derailed, you can lift it back on the track. One of the advantages of moving to 2.5 inches, you look at it and you say, no, I'm going to try, especially as you get older. So I dragged them into that, and they showed me how to do it accurately, and so they deserve a lot of credit for that. At the end of it, I'm going to actually get into some kind of fun background stuff and get into a little of the physics and what you have to consider that a lot of people don't really understand. The good news is, in this hobby, you don't have to understand, because if you get other people who've done it before, you can copy it, what have you. But it's still worthwhile to understand that, and if you go off on your own, one of the things I found about this hobby is it is an absolute target-rich environment to find out the number of things that people have forgotten over the years, and they now do in silly ways, and in ways that can be almost dangerous, at least to get you in a lot of trouble. And so my focus has been a lot of the hobby on bringing some technology back to it and taking an engineering approach and what have you. So I wanted to share some things with you that are fun to know if you didn't otherwise know how important they are into the operation of these. And for those who want to get more serious and get into it, they can carry it further. So that's what we'll talk about. If you're going to do what I just described, you need to pick an engine to model. And in particular, there were 3 of us doing this at the time, and we were picking on these C16 class locomotives that I talked about before. So I'm going to show you modeling of the one that I ended up, of the 3. We built one for each of us, and they were all different to some degree. But you want to pick a legacy locomotive that has some provenance, so it's not just a one-off model that's a free form. And then you want to try and do it as accurately as you can, and with as much detail as you can, and then make it operational. So that was the objective. So if I can figure out how to work this, I think you already saw the locomotive that was selected, if this works, is DNRGW 268, what was referred to commonly since 1949 as the Bumblebee, for reasons that are not clear at all, are they? This engine was originally built in 1882. This picture is about 70 years later at the end of its life, and that was about 70 years ago as well. So you're looking at a 140 to 50-year-old locomotive as it appeared, again, as I said, at the end of its life. And some noteworthy things about the engine. It went through a very interesting history, none the least of which is the fact that it was the last operating C16 locomotive known, and it's one of only 3 remaining in the world, one of 2 that was built by Boller, and the 3rd one was built by Brandt. And it ended up in its last days, just not too long after this picture, pulling up the tracks and the narrow gauge tracks in Denver and Rio Grande, and then it went to Gunnison, where it's sitting in the park now. So it's got some fun legacy. The other engines that were modeled, well, let me tell you about why this one survived. Especially surviving World War II makes it rather unusual, because a 70-year-old, 60-year-old at the engine at the time in World War II would have logically been scrapped, and the steel would have been used for weapons of war. When the Denver Rio Grande, not the Western, Denver Rio Grande Western Railroad was formed originally, not too many years before this engine was purchased, along with about 82 of them were made. And for the first 30, 40 years of that railroad, this was the workhorse of that railroad. So it's got that importance. When over the years, by the 1920s, they started replacing this with the Mikado class, the bigger engines with the trailer truck on them, the heavier engines and the bigger loads and all that. And eventually these were mostly gone, but there was a branch line that had been put in the early 1880s from Gunnison north up to Crested Butte, where there was a little town of Baldwin, and there was a new silver mine up there. And so that became quite a growing place for a short period of time, all those years, a lot of activity. And so these engines serviced that branch line. After the silver mine was closed, they opened up a coal mine. It was a very productive coal mine for a significant number of years, and that coal mine was important all the way through World War II to provide coal to the iron ore factory in Pueblo, Colorado. The problem was that the first time they tried to go up there with one of the bigger engines to bring the coal down, it didn't do so well on the light rail and the small bridges, and everything was put in 1880 to get up there. And so there were 3 of these locomotives left, 268, 278, and 223, which was the Grant. And so they jealously guarded those engines because they were the only ones that could service that line. In late 40s, this engine was actually retired, and it got sent on a mission on its own in 1949 to Chicago to what they call Rail Fair, the big event with all the railroads. And DNRGW used this engine because it was close to the class of the original engines that they had purchased. And they dolled it all up and made it look, they put a name on the side of it to make it look like it was their very first engine, and they painted it in this brand new color for that railroad. They called it Grande Gold, or Aspen Gold, referred to as both, and sent it off to Chicago. Of course, it couldn't drive it on the rails because this is an air gauge engine, so it's a 3-foot wide. So they put it on a flat car, sent it there, and it spent a year in Chicago advertising this new color. But it had a great big wooden pilot. The thing that people call a cow catcher out there was made out of wood, and it didn't have that knuckle coupler. It had a great big drawbar on the front. They put a big kerosene lantern on it. They put a great big diamond smokestack, and they made it look older than it is here. Well, this is substantially different than it looked originally, but it went back and represented them. And after that fair, it came back and they donated it to the city of Denver. And funny thing, on the way to Denver, 278 that was servicing that mine needed to go in the shop. And so they needed this engine back in service. So it got withdrawn from the loan to Denver, put back in service in this color scheme. So that's what you're looking at right here. This is in the mid-50s. End of life for the engine, last operating one, and it was back there to service the Baldwin branch of the railroad, and then it got the duty to tear up the rails and put things away. So that's why it was of value. The other thing that's valuable if you're going to do this, you either need to get the detailed plans or you need to have access to the engine or something to figure out how to do it accurately, or a very good set of photographs. And the engines we chose to do, 268, 278, 223, all still exists. So we decided we're going to model them as they should be modeled. So after this came back from Chicago, this is partly what it looked like when it was at Denver and in their hands. And you can see the big wooden pile up front, the kerosene light and all that. But it does have this legacy, and in fact, that branch line that was up to Baldwin has a location halfway between Dennis and Baldwin called Jack's Cabin. This is the Jack's Cabin water tower, and here is 268, and next to it is 278, which was the engine that it helped share the duties at Baldwin with. And the thing that's most unusual about this photograph is that, remember I just told you the story about the fact that this is a light rail and all that. And you see in the back there, there's a K-27 464. And that probably never really saw service up there, so it's not clear exactly how we got that photograph. Oh, wait a minute, I know how we got that photograph. I remember now, that's not real engine, that's us. So this is at Ron Schmidt's at the Flint Region Portola Valley Railroad, which is no longer in existence, and a photograph of Ron's two engines, the 464 and the 278, and my 268. I mentioned that there were 3 engines built, so let me show you what the third one was. So this is 268 and 278, and this one is 268 also. But the difference is, this is what Peter modeled, and this is 268 in the 1930s. And it was servicing Durango as a switch engine, so you notice that on the pilot they knocked out the boiler tubes that are there and put a big wood plank through there so that the brakeman can get up and down and the switchman can get up and down off the engine. The plumbing's different, what have you. So these engines are all accurately detailed and all differently. You can see 2 different vintages of 268, 2 different units. So let's move ahead here. I want to go through this first part a little bit rapidly because I've got a lot of pictures that just show detail. One thing you have to have is you have to have the right color. This is actually 268 in Gunnison, Colorado, and that is a color chip which we've got. It's the actual DuPont color from the railroad. It goes back to the real formula, and that was so that it could be made the accurate color. Had I not met with these guys, I probably would have done it Caterpillar yellow or Think Track orange because I had the paint. But they persuaded me to start doing these things quite accurately. So a couple of photographs of the engine in service. Here it is when it was brand new. I'm going to come back and talk about this funny thing on the front here because if people don't know what that is, they always ask about it. So it's just a view to show it sort of new. Here's another picture of it with an appropriately colored consist. My wife and I like this because it shows the right colors. Honestly, this engine probably never really pulled many passenger cars because it was usually used as a freight engine. The Mikado class would work the branch lines in where the freight where the passengers would typically go would be, from Denver and Pueblo and places like that over to Durango in that area. And this engine had obviously been there, but it did work these smaller branch lines, mostly servicing the farmers taking sheep and cattle, and also servicing the coal mine and the silver mine I mentioned. So this is the other side of the same engine, and you could look at the detail. This, of course, is the model. And when I originally gave this talk, I was invited by engineering Professor Stanford to come and talk to the engineering school about detailed modeling, and we played a guessing game, intermixing pictures of the real locomotives and the models, and it was gratifying that they more often than not got it wrong in some detail. So going a little further with the details, let's get a little closer to the, whoops, what did I do? I hit the button. So, can I get back?
Hi, sir.
Let me try this. Let's try that. Oh, that didn't do it. Okay. My thumb slipped down and I think I hit that button.
Oh, yeah.
Okay, so get exactly where I was.
This lecture is actually sponsored by YouTube.
If only.
Aha.
Right, which one are you on?
Well, how about slide 11? Get down to 11. All right, close enough. Good, thank you. I'll try and be more careful. They do that with TV at home too. It gets me in trouble. Doesn't it? If you look more closely at the, I mentioned that I was going to show the item on the front, so let me bring this to your attention. This is kind of a fun thing to have added to the model. This is basically a brake cylinder mounted on the front of the engine. And I know a lot of railroaders would look at that and say,
Wow.
what is that? It gets more questions and more intrigue. It's one of the two things besides the color scheme that draws attention to the engine. And so I thought I would, for those of you who know railroading, you might recognize that this I took off of because it was easier to bring the whole engine here. This is called a flanger, basically a little snowplow. But in this case, it has these notches in it that go over the rail. And these were mounted usually on a separate item by themselves. They were pushed by the engine or pulled by the engine, and they would take the snow and the ice right off the rail area. So there's a picture of the flanger, and this one was mounted underneath the pilot. So up underneath, right up underneath here, it sat down like that, but back in there, and had that cylinder put on it so it could be raised and lowered when you go across the grade crossing or across the switch. So that actually is operating. I get to claim that that's exactly accurate as to what it actually looked like. And anybody who questions that, I get to say, so how did you do it on your engine? And I've had a lot of conversations about that. Back to the part of the selection of the engine and part of the advantage of building an engine you can get access to, that flanger has long since been lost. It's not on the engine. There's very few pictures of it. But if you go back to Durango, to Gunnison, Colorado, and you go out there and you look at the engine, there's holes in the pilot deck, and you can go measure those holes, and those are where the holes are. And so if anybody else knows, that's the way it is. And I'll take on anybody who has that.
So it was used to raise and lower the flanger?
It raised and lowered the flanger from the cab
Yeah,
using steam or air. Yeah.
so to get through a switch.
So you get through a switch or through a grade crossing. Yeah. So it raised a lot of questions, and so it's kind of fun to have it on there.
Do you think that was a one of a kind?
As best I can tell, it was only one or two. There's a chance that there was another engine that tried to do that the same way. There were engines that put flangers like this on the engine. There were some K-class engines, I think, that had it on out front, and they had a great big, like in those days, you know, they had a steel bar, about an inch diameter steel bar would have a big lever and pull it up and down. I don't know how successful. In general, they were usually put on a truck and they were pulled or pushed by the engine, hooked in a couple of it's a separate car, same as you would with a spreader or a snowplow or something like that. They did mount snowplows, of course, directly on the engines. The K-class engines at Durango and Cougars have the 487 has that almost year-round on it in China. So I want to get into a little more detail. So as an example, if you look at the left side, this is the left side of the engine. And needless to say, here's the piston and the cylinder. Here's the valve up here. This is the piston rod. And this is the valve rod. And you'll notice in here that the piston rod connects to the alligator on the crosshead with this tapered rectangular pin. Okay? So just recognize that it goes through a 45-degree angle. Notice all this frame back here is a single piece of steel. If you go to the other side of this engine, so, oops, this one there. Let me see. I see the slide. Oops. I don't know what happened. We lost the slide. Well, you'll have to take my word for it. But what I will describe to you on the other side, this pin goes through at a 90-degree angle crosswise, horizontal around. And this piece here, starting about 2/3 of the way up, is twice as thick. It's doubled up because this engine obviously had an accident. This bar on the other side was fractured and broken, and it has a double on it to strengthen it. So the model has that. And I assure you, you can look on here, on picture, that pin on the other side goes at 90 degrees. That's a detail which we wanted to be sure and and noted here. I want to point out one other thing. Notice the sand tube down here for letting sand down on the tracks. We'll come back to that at the very end. We get talking about the technology. One thing you can't see on this engine has got a valve gear that changes the direction of this valve rod relative to this piston rod for making the engine go forward or reverse, or controlling the amount of steam that is admitted to the engine. We'll talk more about that as well. But in order to do that on this engine, the valve gear is inside between the frame. So that was just a picture you saw before. So this is the engine with the boiler missing, and that's the smoke box up front, and you'll see all this stuff down in here. So now we're starting to get into that area where if you're going to do fine, accurate modeling, you have to include all that stuff. And you can include all that stuff more easily if it isn't operational and isn't precisely critical. That's what I said, if you're going to run it on live steam, that has to all work. And so if you look closer at some of the detail, everything in there has to be to a specific calculated dimension in order to make it in a very particular way, because it's functional. And actually, what it basically does, remember I said that you have the piston rod and you have the valve rod. And the piston rod goes back and forth as the wheels go around, and the valve rod can either go with it, or it can go the opposite direction, or it can stand still where that goes like that. And that's forward, reverse, and neutral, so to speak. And that's all controlled from the cab. So let's go up and look at the cab, some of the detailed clips. Aha! This was to show you what I just showed you, as is this one. Basically what it does is the valve is up here and the steam either goes in this side when the wheels are in one direction, or if the valve spool is going in the opposite direction, it lets the steam go on that side and pushes it the opposite way. So all the railroads here know how that works. So if we go up to the cab now, we'll start to look at some of the controls and how you do that. So this is a view to the window. This is what usually fools people because they think they're looking at the full-size engine. If I pull the cab off and get up closer to it, here it is. And so some of the operating valves. So this thing here is referred to as the Johnson bar, and that's the thing that makes all that mechanism down inside the engine do what it does to make the valves do what I just told you it did. This is the throttle up here. This is the train brakes. And this is the independent brake, which operates the brakes. These are air brakes on the engine and its tender. And up here is called a displacement lubricator. That is a real interesting technique to get oil in the steam line that goes to the cylinder to lubricate the cylinder. This is a phenomenal invention. One thing I love about this, you go back and these guys did things 150 years ago that are just beyond belief. This is one of those. This was invented by a guy in France. It's a lifting injector. Basically what that does, sort of feels like a perpetual motion machine unless you get into thermodynamics. It basically takes steam out of the boiler and runs it through a venturi and picks up water from the tender. And then the combination of the water from the tender and the steam are re-injected back into the boiler against the very pressure that it came out at. And we can get into the physics how it works. It's really marvelous, but basically uses the thermodynamic energy from the engine to inject water. That's how the water is picked up. And you have to put water in these pretty continuously. An engine like this would typically, whenever you're working, you would need to stop, fill its tender full of water every 25 miles or so. It would carry enough coal to go through a day or half a day, but you just went through a lot of water. Speaking of the water, one thing you need to do, of course, is you need to make sure that the water remains above the fire. If it doesn't, the fire is more than hot enough to melt the steel. And so if the fire is completely surrounded with water, it will melt the crown sheet. And there's ways to keep that from happening. There's a sight glass, which is just out of view here. But this is called tricox. These are 3 valves that go directly in the back of the boiler. And if you suspect that you have low water, the engineer or the fireman can turn on this valve and it just lets pressure come out inside the little nozzle there, and it just blows down. If it's blowing water, you know the water's above that. If it's blowing steam, well then you move down to this next one below it, and you turn it on. And if it's blowing water, now you know the water's between the two. If it's blowing steam, then you go down the third time. If this one's blowing water, it's still okay, but you have to some water in it. You're about to have a bad hair day. Do something quite rapidly. That's some of the detail in the cab. I'm sorry?
Did you make your own appliances?
Some of them yes, and some of them no. I talked about Ron Schmidt and his hobby. He caused a lot of these to be made for us and then available to the hobby. He sort of talked about, you know, philosophers and artisans 2,000 years ago, and how you have, you know, people doing paintings and what have you, and so he figured you could use your money in the same way, just have this be your hobby instead of paying a Rembrandt to paint some paintings. And so he contributed significantly so we could all benefit from them. And so some of these things have come from that, and some from some other elements. Okay, I want to keep my eye on the time, so
But a quick question.
yeah.
This was not made from a kit, and did you do this from like the drawings of the construction of the locomotive so you could get all these things to work right?
We had a drawing of the frame of the Grant locomotive, which is close, and we had, before digital cameras, the engines existed, and there are shoeboxes and shoeboxes and shoeboxes of photographs, mostly from Peter and Ron, who made numerous trips to Colorado every time I had to figure something out. And it got to the point where I memorized these photographs so well, if you gave me a photograph of that engine and another one, I could tell you whether it really was off that engine or not. You could sort of memorize it. But we basically drew up most of the parts ourselves from that and fabricated as much as we could, and then got some parts from other people who were doing the same thing. And some of them are available commercially. This hobby really met a sort of a high point with the aid of these people I talked about a few years after we completed these. And since then, there hasn't been so much work in this level of fine detail on these legacy locomotives for this purpose in this scale.
Wow.
So now we got a great little engine, and it's noteworthy to talk about. When I showed you the 3 engines back there, when we run the engines together, people seem to gravitate toward the Bumblebee. And my friend said that's because blondes always have more fun. I suppose it's true, but we had to have a Consus to go with this. It was equal to that then. So now it's embarrassing if you don't have some cars to pull that like it, and so I had to pick a car to go with this. And it was my good fortune that Caboose 0589 happens to still exist, and in fact it's in the same yard with 268 now. And this isn't exactly correct. This is the real one, but the lettering isn't exactly right as it was in 1955. Somebody did some restoration work on that and they got it wrong. So we have to go back and do it right. But from the outside, here is the way it really looked. This was a lot of a fun project, so I'll show you a couple pictures of get into some detail. We'll go through this fairly quickly so I can get into the other comments. This is the rear of that caboose at our railroad up here sitting in the station. And you'll see these railings here. You'll notice this railing has a round corner on that side. If you look more closely at that up here, you'll see that this one actually on one corner has that railing there, because clearly at one point in this caboose's life, before 1955, that railing got damaged or got lost, and they pulled one off another thing and they stuck it on there. So if you're going to make this correct, that's accurate. Some other detail. This is the inside of that caboose looking back, and you'll notice the two berths up here, one on each side that fold down. This is a kitchen cabinet, and there's a table here that folds up that closes that off and sits down, and some cushioned seats and what have you. None of you looking the other way. It looks a little sad. They are actually collecting money to restore this. This is the conductor's desk, and notice a little lantern here. You'll see some things on the walls, and there's a pot-belly stove, and there's a missing water heater there. You see these stairs go up into the cupola and what have you. This is that bench that I showed you. This is the conductor's work desk. But you see this chair, which is, or this seat that's behind me. You notice the number of screws and the location of those screws there, because when you model it, it has to replicate that. You have to have that lantern we talked about. You have to have the fire bucket. This is kind of fun. I'll talk more about this later. Here's that stove. You'll recognize the stovepipe. But in this case, now the water heater is there. So it's a big water container that was next to the wood burning stove that you would get the heat from that. There's a sink back in here. The kitchen, or the eating area that I talked about is behind me. So we'll take a closer look at that thing that was up above his head. Oops. I got it. Now button it again. What do I do? I do this, where I find it. There we go. That's the thing that's framed up on the wall above the conductor's desk. And that's very, very important. I don't know if you can read that, but it basically says, well, what it is it's the list of the stationary requirements that are kept in the engine. And why they had to frame it on the wall, I don't exactly know. But of course, it had to be duplicated. That's that same. I know exactly what the stationary goes in there. And you have this other device up there, and we'll go a little further. If you look at the seat cushions and you look at the buttons and you count the number of boards and the color they are and all that, and then there's the seat cushions been duplicated. And this shows those bunks. And this is my wife, Holly, who got engaged and decided at that point this was going to be a real thing. So this ended up with some wool blankets and some down pillows. And they align quite well with what you might find in the real one. And so I'll just step through these so you can see the details. But the model actually follows that the chains are appropriate. They have the same hooks. And you notice this lantern here, that's that cabinet, and there's the table folding down, and you can guess, now you already know the drill. You can count the number of buttons along there, and when you get to it, you'll find the same number of buttons, and that folds up just like it's supposed to. And that's another view of it looking back to the inside. This is the lantern, which is mounted on a swing-out board and is held by this, so you can put it around the side and look, see from outside in one way, or you can swing it back around. And so, of course, we have to have the lantern like that. And now here it's been occupied, and somebody's moved in and brought in their utensils and started to live in there. Let me jump ahead in my notes here so I can see where I am. Got to keep just one step ahead of you.
Now
Okay, okay.
this photo is your model.
Yeah, this is yeah.
Wow.
There's a long story about that and getting access to it. If there's time at the end of it, I will tell you. It's really intriguing. So if there's time and you have to ask, I'll tell you more about that, but I'm going to skip down because I want to get it done in time to do some other things. So here's the sink, and notice what's missing here. You see this tray here. There's a cold water. I showed you what the heater was. And there's a cold water version there you can put ice in. And so there's the in process to being built sink. And let's see, do I have a picture of it? Yeah, there's the sink done. It's back there, and there's what the cold water storage thing would have looked like if it were still in there. And another picture looking backwards. And from here, if you look up here in the upper area of the cupola, you'll see there's a conductor's brake valve up there, and there's a little frame thing up on top of that. And notice it says here 4 tradesmen only. And you notice the word 4 is hard to read because it goes right down the crack where the board is. So this is that sort of that same view, but in the model. And if you look more closely, there's the 4 tradesmen only sign and the brake valve and a picture. And that's what the picture is. It shows how the valve works. And there's the model. And you'll notice the word 4 is half into the crack because that's the way that it was. So those are the kinds of details we went through. I'm going to shift gears now and say that you've got an engine that's highly detailed, and you've got a train that goes with it that's highly detailed. Now you need a tractor runner on that's highly detailed, and so I want to get into something about the infrastructure for the railroad. So this is our railroad up here in the hills, and this is a photograph just taken a couple years ago. These are different engines. This is my then K36 locomotive. This is the same gauge as this engine here, but it's in a different scale, because this is a 2.5 inch to the foot, and this is 1.5 inches to the foot. And that's because this knows the railroad rails are 3 feet apart, and this thinks they're 4 feet, 8.5 inches apart. They're wrong, it's 3 feet apart. So that's why that engine, which is a smaller railroad engine, is, first of all, it's bigger because it's a bigger engine, but it's also bigger because of the scale that's changed. And up here is that K27 464 Polo electric, the cars that go with this engine, and this is a representation of a authentic trestle at our railroad. And of course, there's a full-size caboose up there because I have a full-size caboose. But I want to make some points now about modeling when you get to this scale. So I'm going to bring up one more slide, and then I'm going to take a break for slides, and then I'm going to come back to them. So, oops, let me jump ahead of these. Let me jump ahead. So you can make it twice as long. Here we go. This is a full-size engine on a full-size bridge in the U.S. And if you look at that, your mind will tell you the bridge has to be about this size relative to that engine, otherwise I wouldn't want to go across it. So when you scale model stuff, things are not always linear. So the different things which perform the physical functions of the engine scale at different rates than the single dimension. And I'll give you an example of what I'm talking about. So this was my wife's idea. So there's a wrench, right? If I wanted to model that wrench, and I want to model it at 1/5 scale, that's the wrench. So that's 1/5 that length, and it's about 1/5 that dimension, and about 1/5 that dimension. If you want to model it 1/8, which is that, it's that one there. So this is the difference in size there. But what's interesting is if you think about it, you said, okay, so let's take this little one. This is 1/8 the size of this. And that's in any linear dimension looking at it, single head. But if I took 8 inches that size, here's 8 inches that size, that doesn't weigh the same. So what's going on? Is this 1/8 size of this or not? Well, if I ask you, you want to add to your house and double your house, You might say, well, my house is 2,000 square feet, so I'll have 2,000 square feet, I'll double the house, it'll be 4,000 square feet. Does that double your house? Doubles the floor. So let's play a little game. Suppose that's my model train. That's my engine, right there. And I said I want to model it in 1/2 scale. So this is the length, and this is the width, and this is the height. So I want to make the engine half that big. Well, from where you're looking at it, just say, well, let's make it half as long. So I'll just take these away. Now it's half as long. But it's twice as wide, so it doesn't look like it. So I gotta make it half as wide. And now it's really tall. It's shorter and it's narrower, but it's tall, so I gotta cut it half that way too. So you could argue that this is half of these 8. And that's really important to understand because when we get into putting the steam in, which is where I want to kind of end this talk, some of the dimensions that affect the use of the steam and the strength of the boiler and all that relate to these other performance metrics. They don't scale linearly. So if that's really a 1/2 scale model of these all together, you can see by the wrench and by this that it's, in this case, when I go by half, it's 1/8 of the weight. You know, that weighs 1/8 what this weighs. But we reduced this scale by a factor of 5 on the big engines. So it's not 2 squared or 2 cubed, it's 5 squared or 5 cubed. So that locomotive is only 125th the weight of the full-size locomotive because the volume goes down by 5 times 5 times 5. And the surface areas that have to withstand the steam are 25 times smaller. And that's because it's 5 times 5. So we're playing with squares and we're playing with cubes, and some things go as the volume, and some like the weight, and things, and I'll talk a little bit about that in a minute, and some go as just the square, like the pressure that the vessels see. Now, by and large, that works to our favor when we're scaling down, because what it means is the weight goes down much, much, much more rapidly than the strength goes down, so things become stronger. So the reason I put this in there, let's suppose you're making a model railroad and you went out and you said to somebody, I've got a model train here, and you go to but I need a place to rent it, and you hire a civil engineer and you say, I want you to make me a bridge. And how much do you pay for a bridge when you build it, how do you design it? Well, the bridges are designed with a chosen safety factor, a number like 2 or 3, and the reason you don't make them stronger than that is because they become ridiculously expensive. You know, the Golden Gate Bridge, when it's loaded with people, everybody knows that it sags. That's the good news. If you made that so rigid that it wouldn't sag, it'd be solid third all the way down, and it would be very, very, very expensive. That's why if you drop a grape from a tree, it can bounce. You drop a watermelon from a tree at the same height, and it'll usually burst. That's why something as small as a mouse can fall out of a tree and hit the ground and get up and scurry away, and elephants don't do so well. That's why elephants don't fly and they don't land in trees. So what happens is the mass grows at a greater rate than the dimensions that affect the strength. So you can't build a steel bridge to the moon because at some point in time the steel itself has so much mass and so much weight it can't even hold itself up. And again, I say that's why elephants don't fly. So you run into that issue, if you design that bridge so it matches that railroad, nobody would ride on your train with it. It'll work because our engines are that, steel's that strong and the material's really that light. So we build our things to the best of our ability to meet your visual demands. So, you know, Walt Disney did this to you when you go to Disneyland or you go to California Adventure, you look at Main Street, and it really gives you this wonderful feeling you're in this big town. You go and you walk in the buildings and it's kind of cozy and kind of nice. But he pioneered, and they use, it's called forced perspective. The first story of all the buildings, a lot of you know this story, the first story of all the buildings is 7/8 the height of a real first story. The second height is 5/8 of a real story, and the third one's half. And so the buildings give you this dimension.
I'll wait.
Okay, they give you a perspective. When you go into the California Adventure, you look down as Hollywood Boulevard or Buena Vista or whatever street it is, and you get this wonderful perspective looking them out in the end, and he's playing with your mind. So we need to do some of that too, just to give the visual effect. We need to do it for another reason. Did you want to ask?
I had a question. We're talking all about the scaling and the size of the trains. My background is in chemical engineering. I can tell you that fluid dynamics works very differently at smaller scales. What is the highest or smallest miniature you could make and still have it be a steam engine?
You know, I don't know the answer, but the first question I'd ask you back is, does it have to include the heat source in making the steam, or is it just driven, a steam engine driven with a pipe steam to it?
I mean, have to include the steam,
Including building
yeah,
it?
yeah.
I don't know. I know that there are, somebody in the audience might know there, somebody out there in Zoom land might know. I have been told that there have been some very small steam engines, like, you know, HO scale and smaller, that actually operate and burn alcohol in themselves. I guess this is not in it. There are some people that know this. I don't know the answer, but you're absolutely right. In fact, with the coal, one of the things with the chunks of coal, ash from coal, doesn't scale down.
Yeah.
And so you have an engine like that that I modeled there might have a couple hundred flues that are 2.5 inches in diameter for the hot gases that go through. Well, that would get, in the scale down side, plugged up with coal soot pretty quickly, and you could have a problem. So that engine has a couple of dozen flues, and they're 3/4 inch in diameter, and you can't see them, so you don't know. But there's a lot of things like in there where you have to make those trade-offs.
If I may, at the last Portola Valley Tri-Club meet, I bought a Victor Shattuck locomotive there. And that locomotive, I believe, is 1/2 inch scale, 2.5 inch gauge. And his locomotives and I put videos from 16mm films up on YouTube, which I'm going to send this gentleman. But they're using alcohol instead of coal. So you don't have the particulates you're talking about. And again, possibly like your locomotive, he was making these before there were kits. You know, and it just blows me away. And there's this big slide rule on the wall over there. And forgive me, I guess I heard that you're a mechanical engineer working for HP, which I think would be more of electrical engineering. But did you do this partially for your enjoyment of steam, or partially for the engineering challenge, or partially because you're a little crazy?
So the answer is yes. Did that just go?
Just press.
Oh, yeah, let me see if it'll come back.
Yeah, went to sleep, I think.
Went to sleep.
I will bring it back to
Wake it up, I got
Ooh.
2 more slides I want to go through.
Cool, I can change tapes in the meantime.
There we go, thank you.
Because I'm shooting digital tape.
I want to make one last point, and I'm going to kind of summarize why I want to take this little shift in. This is the called the back end. That will all get welded on the back of the boiler, and this is the firebox door. And through that door, you go into this, which is the firebox. And the fire is down here on a grate in the bottom of that. And you notice the water covers all around that, and halfway in front of this full length, this firebox ends, and then it's just the tubes that go to the round part. So this is where I talk about, this is the crown sheet, this is the area you gotta keep water on top of that, because if the water gets below that, then the fire here will just melt down and the whole engine will blow up, and that's how these things are supposedly blown up in the past. But when you model this, if you look at this outer wrapper here, boiler, and the firebox is made out of the same steel, that's nominally a ½ inch thick. That's the exact same boiler steel that the full-size engine is made out of. So that's 1-to-1.
Well, 100 PSI is 100 PSI.
I'm sorry?
You can't scale 100 PSI.
Well, you don't need to scale the PS. You're right, you can't, because the efficiency out of the fuel is the same regardless of where it's used. So we run our engines anywhere from 100 to 150 PSI. The original that engine ran at 120 and then 135, and then they went up to 175, and then 250, and eventually 300 pounds. But the 100 to 150 is a good number to get the efficiency out of the coal. But my point is, if you make this out of steel and you put the appropriate stay bolts in it to make it strong enough, it's so thin if it's scaled down that it's subject to rusting through. And if it gets weak from rust, you could have a problem, what have you. So therefore, we want to make it thicker for a lot of reasons, but one reason in particular is, I already told you about the weight of the engine. This engine only weighs 125th of what the real one weighs. And the ability of the engine to pull things is directly proportional to the weight of the engine. Okay, the formula for that is really simple. You take the coefficient of friction of the surface and the normal force is the weight. Those are the only two things that really matter. The number of wheels and the size doesn't matter. The caveat, if you have incompressible materials, and these are steel and iron, they're largely incompressible. What that means is locomotives add wheels, not for the reason a lot of people might think they do. They don't add wheels to add tractive effort because you get a greater pulling because you've got more tires on the front of the car. It turns out that has no effect at all. It doesn't matter whether the engine's sitting on 4 wheels or 8 wheels or 10 wheels of the It doesn't matter for the purpose of adding the tractive effort with a caveat back to. But it sure as heck matters to the rail that's feeling the weight. So you add wheels to spread the weight out on the rail. You're not getting additional tractive effort. That seems counterintuitive. People logically think, if you have a bigger surface, that you get a greater resistance. You don't. That's just the way it works. But you do drive more wheels because I said it's two ways, just the weight and it's the coefficient of friction. And the coefficient of friction can be changed if a cow left a cow pie on the rail, which you can see pictures, or it's wet, or it's icy, or it's snowy, or it's water, or what have you. And so if you have a wheel that would spin because the coefficient of friction has gone down and is connected to another wheel which isn't on that same cow pie, then it can continue to go. So there's logic behind it all in why you do that. So Shea locomotives have all the wheels drive. Again, they have lots of wheels to spread the weight out over an unimproved railroad, but that's not to add the tractive effort. But you drive all the wheels because of the reason I described. And I mentioned earlier on, I showed you the little sand pipe that drops sand down the track. That's how you solve that problem. You drop sand on there, it increases the coefficient of friction that would otherwise be gone. So the reason I took the time to go into that is that, and I mentioned the fact that this hobby is target rich for things that people don't understand, which again doesn't matter if you speak with those that do know in coffee, but sometimes there are issues in the railroad, and I run into them more times than I care to admit, where a well-intentioned person tries to persuade you based on logic, which seems necessary, and they are making oftentimes precisely the wrong decision, if there is such a thing. So I think it's healthy to understand that you should go to a technical source if you have a technical problem, and respect those that figured this out 150 years ago. They're smarter than a lot of us. And if for no other reason, then you can appreciate and respect the fact that there's a lot more science and thought that went into these than people might realize, and I think that that's kind of intriguing and kind of fun. And so yes, the answer to the question is we do it for those reasons. In my case, when I went to work at Hewlett Packard, I actually started as an engineer with an MBA, and I had one of those in my pocket, and I immediately got signed to a project called HP 35, which was the versatile transit general function handheld calculator, and as soon as we could and had it working, I bought a brand new one of those as a graduation present, used it for 1 year and never used it since. And so your reward sometimes for, I guess, doing a good job as an engineer is they take your slide rule and your calculator and your drafting board away from you and just say you don't get to be an engineer anymore, you've got to manage other people doing that. And so I have resorted to my second childhood and said I'm going to go back and be an engineer, and so I refuse to be a manager of this hobby, and I adhere rigorously to finding technical problems to argue about and solve, and with this target-rich environment, I've been fortunate to have written some papers and had some things published dispelling some, as I said, well-intentioned but misdirected activities, and this is a fun opportunity to share that perspective with a bunch of people that can now appreciate and enjoy that as well. So that leaves us right on schedule, but I'm willing to take some questions.
Wow.
So even given all the scaling issues and having to use full-size steel for the boiler, what's the overall weight of your engine?
An engine like that is 150 pounds, maybe, I'm guessing. An engine like the Bumblebee that I showed you there is 800 pounds. The engine that was at the bottom of the big trestle in that picture is 4,000 pounds loaded. And as I shared with somebody coming in here, part of the beauty of going up scale, when you build engines this size, no matter how old you are, you still believe that you can pick them up when you make them. When you shift to the 2.5 inch scale, you take one look at it and say, I'm not even going to try. And it gives you an opportunity to invent ways to put the engine back on the tracks.
My engine is an 040T saddle tank, and I can get on my knees and grab it from the front and gently put it back on the tracks.
And you have my permission to get in your knees and try to lift my engine.
Never, never, never.
As well.
Wow.
Okay.
The pictures of your mechanisms were gorgeous, but they were too clean. I mean, you must do a lot of oiling and greasing as well.
Well, an interesting story. So when I first built that engine, that one photograph had a copyright from Mike Massey, who's a very well-respected photographer in this hobby. And Mike was there when the engine was brand new, like you saw it there, and he said, well, I'm not going to photograph it, it's like a toy. Wait until it gets some ambiance. And in fact, you know, the HO modelers pay a lot of money to do the antiquing and what have you. I sold the big engine to a group out in Southern California, and they very, very much want me to bring the Bumblebee down there to run it. And one of the more experienced guys down there said, don't you dare ever paint that engine. It looks just like the real one, the more it runs and the dirtier it gets and what have you. So there's a group of people want me to leave it like that. I kind of, I don't know, I'm thinking of taking it apart and the idea of getting it all to paint it again, but I'd like to leave it to my grandson, maybe looking like a new engine. So I don't know if they're right.
And it's a gorgeous locomotive. I'm recording this tonight. At some future date, I hope to incorporate some of your locomotive under steam operating along with this presentation. Another thing with me, my engine was built from a kit. And the first 3 times after it was assembled, I was pushing it around the track. And I was pushing it around what's called the shortcut. You did all this beautiful math and all this beautiful engineering. Did it take you a while to get the Bumblebee running? But right now it runs beautifully, by the way. But
people ask how long it took to do that, and I answer one of 2 ways. I either say, at that time, I built 5 engines, and here it is. Or I lie and say, yeah, it was a couple of weeks. And I leave it at that. My wife reminds me this project actually took many, many years because it was started over for a variety of reasons. I mentioned earlier, I actually started this project building 4 engines with 2 other guys a number of years ago. Actually, to share another story with you, there was a professor at Stanford who was into this hobby. And when I first was in engineering school, I went in the student shop and I saw his engine in there. And I immediately said, wow, that's what I want to do. I'm going to go and find that guy. I went and found him, and the first thing he said is, do not under any circumstances start doing this while you're in school because you'll flunk out. Which is true. Marion knows this professor. He actually flunked out of Stanford as a professor. He didn't get tenure because he spent a lot of time working on railroads, so you know exactly what I'm talking about. And but we started this together, and for a variety of reasons, it just was never going to get one engine sort of working on air and what have you. And the other 2 guys, it was like working with Felix and Oscar in the Odd Couple. It really was. I mean, these guys had just extreme opposites, so much so that so we put the project aside. And then Ron and Peter, that I talked about, came over and saw it. And Ron is a very, very, very knowledgeable railroad narrow gauge. If you want to have that lecture that you said this was about narrow gauge railroading, that's the guy, or was he still alive, that you'd want to have come and talk to you. So we decided to start the project over. Ron saw it, so he was just enamored. Gotta have one of these engines. He recognized what it was, but immediately said, but this isn't quite right. This isn't. And so gradually, one part at a time, we sort of started replacing parts. And as I recall, I know the cylinders I made the cylinders, they used the same cylinders. And there may have been 1 or 2 other things, but everything else was replaced. And I was in a job at the time that had me managing people on 5 of the world's continents, and so it took me longer than everyone else. There's a video on this about the fingers that were told on the airline. So I was behind the power curve with the other guys, and it took me longer. And it was probably, how long?
15.
15 years, okay. Working on it part-time, and then when I retired, I threw my heart and soul into it and finished it. Okay, well,
I do have one more question, but feel free to have anybody else answer questions, and I realize it may be getting past our bedtime.
Did you draw the whole thing up in CAD, or how did you start with the layout?
There was various stages, and we actually split the job up. So predominantly 2 of us built the engines, and when one of us would do something, we would do it 4 times and switch the parts. And as I said, Ron's contribution was mainly to help get a lot of things done we would have otherwise done. things done from the outside, and be able to finance the project. So we split it up, so nobody actually ever really built one single engine completely, but we all finished them once they were functional and had all the right parts and pieces. You get your kit parts that have been made, and you got to plumb it appropriately for your vintage and paint it and finish it off in that detail.
But are there drawings now?
Actually, there's a phenomenal set of drawings of cars and things. Unfortunately, there isn't a good home for them. It'd be nice to have an archive. I actually talked to the Palo Museum about making those available to the public. They're in Jimmy Booth's possession and my possession, and if I knew a good home for them, I would gladly provide them so they could benefit the group. But no, there is not a working set of drawings you can go and get. I'm aware of, but you can get bits and pieces from various places.
There's no aspects.
Yeah. Okay, well, I guess we've exhausted our time. Thank you for your attention.
There's food in the back, please eat all of it.
Good, Don. So, HP is well. Great, great.